Namaste, bachcho. Today we are going to learn class 11th physics chapter number 3, force for chapter number 4, force and laws of motion ka. We are going to do the third, I think the fourth, no, second video on force and laws of motion, the second video. So, in the last video, we have already discussed Newton's first and second laws. We have already discussed Newton's first and second laws, the law of inertia, the law of rate of change of momentum. We have understood it thoroughly, and now we have to start with the Newton's third law. Okay, Newton's third law states that for every action there is an equal and opposite reaction. In simple terms, the third law can be stated as follows. Force in nature always occurs in pairs. Force on body A by body B is equal and opposite to the force on body B by body A. You cannot have one force without an alternate force acting on the first force. Okay, so explanation. For example, when we press a coiled spring, the spring is compressed by the force of our hands. The spring is compressed by the force of our hands. In turns, the compressed spring exerts a force on our hand and we can feel it. We can feel the compression happening. If the equal and opposite reactions did not exist, if equal and opposite reactions did not exist, then what would happen? We would never feel the effect of our force. It takes the toll on our body when we apply a force on the other. For example, when I'm standing on the ground right now, my muscles are feeling the pinch. My muscles are feeling the pinch of my weight because I am applying a weight towards the ground in the downward direction. The normal force by the ground is being applied on me, and I can feel that, right? That's why after a long time when we stand, what happens? We feel our muscles gets basically drained, right? It becomes strained because of the fact that the ground is putting a force on us. Also, the earth pulls a stone downwards due to gravity, but according to Newton's third law, the stone exerts an equal and opposite force on the earth. We do not notice it since the earth is very massive and the effect of a small force on its motion is negligible. Okay, so basically the force, the acceleration. So if you throw a pen like this upwards, if you throw a pen like this upwards, what happens? The earth is trying to pull the pen downwards. The earth is trying to pull the pen downwards, so the pen is getting accelerated. Okay, but the pen is also exerting a force. The pen is also exerting a force on the earth. We don't see the acceleration happening because the mass of the earth is very, very high. It's massive. That's the reason why, even though both of them are exerting the same force, we feel the pen going down, but we don't feel the earth coming up. Actually speaking, the earth is moving up in a very, very small value. Every single time I'm dropping this pen, the earth is moving up. But since the earth's mass is so high, 6 into 10 raised to power 24 kgs, that's the reason why we don't see the earth moving upwards. We know that force is equal to what? Mass times acceleration. Force is equal to mass times acceleration. So if your mass is high, if two objects are having the same force, the object with a larger mass will experience a smaller acceleration, and the object with a smaller mass will experience a larger acceleration. Understood? Drupad, it is understood? Okay. Thus, force always occurs in pairs as a result of mutual interaction between the two bodies. As shown in the figure, if FBA is the force exerted by the body A on B and FAB is the force exerted by the body B on A, then according to Newton's third law of motion, then FAB should be equal to minus FBA. Because look at this, when the pen is falling down, the earth is pulling the pen downwards. We can see that the earth is pulling the pen downwards, right? So here we are considering the downward force, the force like this, to be as negative. So the earth moving upwards, the earth moving upwards could be considered as positive because one force is downwards like this, the other force is upwards like this. We are taking upward force as positive, so the downward force, because of its direction in the opposite direction, because of its movement in the opposite direction, we consider it to be negative. Okay, so FAB becomes equal to minus FBA. Force on A by B is equal to force on B by A is negative. Understood? The condition is shown in figure AB. Okay, so FAB, force on B due to A, is in the opposite direction of force on A due to B. Right? Both of them are colliding. Two masses are colliding like this. A is going in this direction, B is going in this direction. Once they collide, what happens? B exerts a force in this direction. Force on B due to A is in this direction. Force on force on A, what do we call it? FAB. FAB is called what? Force exerted by A on B. Force exerted by A on B is where? Wait. Is there a problem here? The condition is shown in figure. Force acting on bodies A and B. Hmm. Yeah, FBA is the force exerted by A on B. FBA is the force exerted by A on B, and FAB is the force. FAB is the force exerted by B on A. Force exerted by B on, yeah. So force exerted on A by B. Okay, that is much better. So some important implications about the third law of motion. Newton's third law of motion is applicable irrespective of the nature of force. The force acting on and reacting may be mechanical, gravitational, electrical, or any other kind. So basically, even magnetic force will have also have an equal and opposite force acting on it. Now, action and reaction are always act on two different bodies. If they acted on the same body, this is what we discussed yesterday, Dhruva. If it acted on the same body, then the resultant force would be zero, and there would never be any accelerated motion. If two opposite forces, equal and opposite forces, act on the same body, then they cancel each other out. But if they act on different bodies, they do not cancel each other out. This results in acceleration on two bodies according to their mass. Force. The force of action and reaction cannot cancel each other. This is because action and reaction, though equal and opposite forces, always act on different bodies and so cannot cancel each other. No action can occur in the absence of a reaction. In a tug of war, one team can pull the rope only if the other team is pulling the rope from their end. If the other team is not pulling the rope, you are doing nothing. You are just trying to bring the rope towards yourself. You're not making the rope move at all. Understood? Next, some important concepts of Newton's third law. While walking, we push the ground with our feet slightly slanted in the backward direction. Okay, we are pushing the ground towards the backward direction. That is the reason why we are able to move forward. Okay, if we want to move backwards, what do? We push the ground in the forward direction. Okay, so it results in what? It results in our movement in the backward direction. The vertical component of the force of reaction balances our weight, and the horizontal component enables us to move forward as shown in figure. Understood? So basically, the r cos theta is allowing us to move forward. Okay, because we are applying a force in the backward direction. Now, the rotatory lawn sprinklers, the action of rotatory lawn sprinkler is based on the third law of motion. As water forces away from the nozzle, what is happening here? The nozzle is spraying the water in this direction, right? The nozzle is spraying the water in this direction. Am I right? Yeah. So basically, if the water is coming out in this direction, an equal and opposite force must come from the opposite direction. So what ends up happening? The sprinkler starts to move in this direction. So because the water is moving outwards, the sprinkler will move at the direction opposite to the flow of water. So this sprinkler, if the water is coming out like this, then the sprinkler will move in the backward direction, thus causing a rotation of the sprinkler all on its own. There is no motor, there is no movable part inside the sprinkler. It's only using the Newton's third law. Understood? Clear? Any doubts here? Like basically, Newton's third law of motion. Is there any doubts? Okay, fine. So, a cat of mass 6 kgs jumps on a dining table of mass 30 kgs. As the cat walks around on the table, then what is the average force that the table applies to the cat? Okay, how much force is the cat applying on the table, Dhruva? The cat is applying a force of its weight on the table. Yeah. So basically, it is applying a force of how much we know force is equal to, sorry, weight is equal to what? Weight is equal to mass into acceleration due to gravity is equal to 6 multiplied by 10 is equal to 60 newtons. So it is applying a force of 60 newtons onto the table. So the table has to apply an equal and opposite force of how much? 60 newtons onto the cat. So basically, to stand on the table, the cat has to experience a force of 60 newtons. And who is providing that 60 newtons of force? The muscles of the cat. The muscles of the cat are basically the ones that are feeling the 60 newtons of force. You are only able to feel the weight of your body when you are standing or when there is ground beneath you, right? You don't feel the weight of your body when you are falling to the ground. Have you ever noticed that? Whenever you're jumping, you are basically weightless for a small moment. Why are you weightless when you jump from a building, when you jump from that swimming pools, that this thing, okay, the deck? What happens? For a small moment of time, there is no normal force acting on you, right? Since there is no normal force acting on you, you practically become weightless. Understood? Right? Because there is no reactionary force. There is no reactionary force allowing you to experience the force of your own mass. Right? Force experienced by your own mass, that is your weight, is cannot be experienced by your body without a reaction. That is why we feel weightless. That is why we feel weightless when we are falling. Clear? Drupad, is this accurate? Okay, fine. Let's move on. Now, a truck is moving with a speed of 20 meters per second along a straight line. Suddenly, some sand starts falling from the back side of the truck at a rate of 20 grams per second. Find the value of the external force required to make the truck move with a constant velocity of 20 meters per second. Okay, so what is happening here, Drupad? The truck is losing mass. Am I right? The truck is constantly losing mass. So here the velocity is remaining constant. The velocity is remaining constant, but the mass is not being constant. Since the truck is losing weight or mass without any change in velocity, the momentum changes. When there is a change in momentum, there is a creation of force according to Newton's second law in reverse. Since truck is becoming lighter, it will be accelerated in forward direction. This means force force in it will be created in the forward direction, right? What is happening? While it is losing mass, the velocity may remain constant. The velocity may remain constant, but what is happening? As it loses mass, its momentum changes. What is the formula for momentum? Mass into velocity. Yeah. So its mass is changing, its velocity is remaining constant. So what happens? There is a change in momentum, and a change in momentum always accompanies a change and always accompanies a force, right? So the value of this force could be found out with the formula of Newton's second law. When V is constant at an instant, but mass is varying. When your mass varies, what happens? F is equal to what? ma. The acceleration is remaining constant. The value of v is remaining constant. But what is happening? Your mass is changing, so this can be mutated. This formula can be mutated into v into dm by dt, right? See, what happened here? The velocity was not changing. The velocity was not changing, but its mass was changing. So what did you do? You made the velocity the same, dot dm by dt. You still have force. See, study this formula. You still have m, meters per second square. meters per second square times kilogram. Kilogram meters per second square. You still have a force. Okay, you can have a force. This example is trying to teach you that you can exert a force even with your acceleration being the same. All you have to do is make sure that your mass changes. If either of your mass or your velocity changes, then what happens? You experience a force. Understood? You experience a force. So the F external becomes equal to what? V multiplied by dm by dt. We already know that the mass is changing with a velocity with a rate of how much? 20 grams per second. Yeah, 20 grams per second. So 20 grams per second can be converted into 2 into 20 grams is 20 into 10 to the power minus 3 or 2 into 10 to the power minus 2, right? So 2 into 10 to the power minus 2 times what? The velocity 20 meters per second. So what do you get? 20 into 2 into 10 to the power minus 2. So you will get 40 into 10 to the power minus 2 is equal to 0.4 newtons. So Drupad, if they ask you, can an object experience a force? Can an object experience a force if its velocity remains the same? So a lot of people will say no, but the formula tells us that if its mass is changing, then its momentum is changing. If a momentum is changing, then force is being experienced by the object. Clear? And so, are you having any doubt? Like, I think you are having some doubts. Is it clear? Okay, fine. Next. So, apparent weight of a man in a lift. So, what is happening here? Let's study this. The reaction experienced by a surface on contact of a weighing machine on a body is called the apparent weight. Understood? I'll repeat that again. So, the reaction if exerted by the surface of the contact of a weighing machine on a body is called the apparent weight. So what you experience when you stand on top of a weighing machine is called your apparent weight. Okay, the reading that is shown by the weighing machine is the apparent weight. Let us consider a man of mass m is standing on a weighing machine placed in an elevator slash lift. The actual weight mg of the man acts on the weighing machine and offers a reaction r given by the reading of the weighing machine. Right. So the weight mg is reaction equal to r. Right. The weight mg is equal to the reactionary weight that is shown by the weighing machine. Okay, this reaction R exerted by the surface of the contact on the man is the apparent weight of the man. Understood? Is there any problem with the definition of apparent weight? Okay, fine. So now we consider how R is related to mg in different conditions. When the lift is moving upwards with acceleration a as shown in figure, the net upward force on the man is how much? See what is happening here when the lift is moving upwards. So what is happening? What is happening when the lift is moving upwards, Drupat? See, this is the body, this is the man. Okay, this is the man here. He is on a weighing machine. Okay, he is only putting a force of how much? Mg downwards. Okay, and the surface is exerting a force of r. If the lift were stationary, we could have said that r is equal to mg or r minus mg is equal to 0. Is this clear? Yeah, but what is happening here? The reactionary force is not equal to the mg, right? So the reactionary force, what is happening? The surface is moving upwards. So what is the relative motion? R minus mg is not equal to 0 anymore. R minus mg is equal to ma. R minus mg equals ma because the object is moving upwards. Because the object is moving upwards, what is happening? What is happening? The direction upward we have taken as positive. So the ma value shows that the resultant is not equal to 0. Okay, the man put a weight downwards, the reactionary force was upwards, but the reactionary force was not equal to the weight of the man. Therefore, what ended up happening? The man started moving upwards. Okay, so here we can say that R minus mg is equal to ma. Did you understand what is happening in this formula? Okay, fine. So can I write this as R is equal to mg plus ma, right? So I can take the m out. R is equal to m of g plus a. Therefore, this becomes R is equal to m of g plus a becomes the apparent weight. 100% clear? Any doubts? Okay, next. When the lift is moving downwards, okay, when the lift is moving downwards, then R minus mg becomes equal to what? Where is the lift moving, Drupad? Where is the lift moving? Downwards, right? The lift is moving downwards. We have considered the downward direction to be, we have considered the downward direction to be what? No, 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 no. We have considered, no, no, no. We have considered the downward direction to be negative. See, when the lift was moving upward, we have to understand this. The sign convention is very important. A lot of IIT-based questions usually start their question. They usually start their question with a simple example. So, what is happening here, Drupal? So, we have R is equal to R minus mg is equal to ma, right? Why was it equal to ma? Because the resultant force was acting in the upward direction. So the resultant force was in the upward direction. Because the resultant force was in the upward direction, we said that, oh, the resultant force is positive. Okay, therefore positive. The resultant force was positive. But imagine that R minus mg is causing the movement to go downwards. Downward force will become, how will you represent the downward force? You will represent it like minus ma. Right. If you consider the upward motion to be positive, then the downward motion has to be negative, right? So R minus mg is equal to minus ma. So what happens? Mg minus R is equal to ma. Can I write it like this? Okay. Did you understand the logic, right? So the downward direction is negative. Okay. So what it becomes? Mg minus ma is equal to R. Therefore, if I take the ms common, I'll get g minus a is equal to R. So if you are moving in the upward direction, if the resultant force is in the upward direction, then how will the, if you want to apply a force in the upward direction, your acceleration has to be greater than the acceleration due to gravity. Understood? But if you are moving in the downward direction, then gravity has to be greater than your acceleration. Understood? So this is where it goes. If you, what? If acceleration is greater than gravity, then it is going in the upward direction. No, you cannot write. Can you? Okay. So in the upward direction, what do you get? R is equal to m g plus a. In the downward direction becomes R is equal to m g minus a. Clear? Okay. Next. When the lift is at rest or moving with a uniform velocity in the upward or the downward direction, then what happens? There is no net resultant force acting on it. Then R minus mg becomes equal to 0. Therefore, R becomes equal to mg. Your actual weight and your apparent weight become the same if the lift is moving with a uniform velocity or if the lift is at rest. Clear? So, when the lift is at rest, the apparent weight of the man is the actual weight. When the lift is free falling, now what happens? When the lift is free falling, what happens? The reactionary force becomes zero. See, you are falling like this. The object is freely falling like this. It is falling like this again and again and again. It is falling. It is going down, going down, going down, going down. What happens here? What happens here? The acceleration becomes equal to gravity. The acceleration becomes equal to gravity. Therefore, the reactionary force becomes zero. That is why the man will start to float. He will experience weightlessness till the lift falls down. Okay, he will feel weightless. Okay, so thus the apparent weight of the man becomes zero. Now, Drupad, do you know how astronauts and a lot of people they experience zero gravity? There is a plane which goes straight up for a certain amount of height, and then what they do is the plane just falls towards the ground. The plane just falls towards the ground. It's called the vomit comet. Okay, so what happens when you go straight upwards, okay, and then you slowly start free falling? You all become weightless, and that weightlessness can be experienced by a person for like 30 seconds or 45 seconds or something like that. And they do this again and again and again to make you feel the experience of being weightless. Okay, understood? This is how people experience weightlessness. Okay, when you are freely falling, what is happening? When you are freely falling, your acceleration is becoming equal to gravity, right? So the reactionary force becomes mg minus g. G minus g becomes 0, right? Okay, have you ever heard in movies when people say, oh, he experienced 2 g's of force? He was in a plane, he was going straight up, he was experiencing 2 g's of force. You know what that means? The reactionary force, if basically if you are in a plane like this, if you are in a plane like this and you're moving straight upwards, you're moving straight upwards like this, or you're accelerating upwards like this, what ends up happening is that the reactionary force in this case when you are going upwards, what is it? Mg plus g. If you are going straight upwards with an acceleration of g, what happens? You experience 2 g's. That's what 2 G's come from. 3 G's, 4 G's, 5 G's, 7 G's. So, what does the person experience at this point? When if your weight is 100, let's say you weigh around 50 kilos. Okay, if you weigh 50 kilos, then if your mass is 50 kg, then your weight will become equal to 100 kgs, right? 100 newtons. If your mass is 50 kgs, then your weight becomes 500 newtons. Correct? Mass 50 kg, so weight becomes 500 newtons. Now think about this. Yeah, any doubts? Yeah, so if a person is traveling straight upwards, you know how much weight he will experience? He will experience 1,000 newtons of weight. 1,000 newtons. He will feel double, double his weight. It's like you carrying another person on you. 3 G's, he will experience 1,500 newtons. If he's accelerating with twice the acceleration due to gravity in the upward direction, he will experience 3 G's of his weight. Understood? This is what pilots have to experience when they are when they're turning sharply. Why do people lose consciousness? Okay, the pilot loses consciousness because all his blood is getting drained out from the brain, because the blood is flowing downwards due to the weight, due to the excess weight experienced by the body, sudden excess weight experienced by the body. So he loses consciousness. So this is what the pilots train for, to experience this g force. Okay, this is what they call g force. The g's, this is what it means. Understood? Yeah. Next. Now, this is because the lift and the man are moving downwards with the same acceleration and g, and so there is no force acting on the body, and the reaction force becomes equal to there is no force of action and reaction between the man and the lift. Hence, a person develops a feeling of weightlessness when the lift falls freely under gravity. When the lift falls freely under gravity, he experiences weightlessness. So, question number 10. A man of mass 70 kg stands on a weighing scale in a lift which is moving upwards with a uniform speed of 10 meters per second, downwards with a uniform acceleration of 5 meters per second square, upwards with a uniform acceleration of 5 meters per second square. What would be the reading on the scale in each case? Okay, Drupad, what will be the reading on the scale for the first case? Uniform speed, Drupad. Uniform speed. If he's moving with a uniform speed, what will be the scale's reading? Not 70 kgs, Drupad, 700 newtons. Uh, they should answer with 700 newtons, right? Yeah, you should answer it with 700 newtons, Drupad. A weighing scale in a lift moving. Yeah, 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 yeah. The weighing scale shows you the, yeah, you can say that, okay, fine, fine, but the actual answer should be 700 newtons. Okay, just keep that in mind. Okay, you are correct, he won't experience any force, therefore his weight will remain the same as that of his actual weight. The reaction force will become equal to his weight. Okay, downwards with a uniform acceleration of 5 meters per second square. Now, Birpat, if he's moving downwards with an acceleration, will his weight increase or decrease? His weight will decrease. Exactly. Okay, and how much will it decrease by? F is equal to mg minus a. So, yeah. So 10 into 70 into 10 minus 5, which is 5. So 70 into 5 is 350. His weight will become half. Correct? His weight will become half. And if he's moving upwards with an acceleration of 5 meters per second square, then what will happen? 17, 15 sevens are 105. Right. So he will basically experience a weight of 105 newtons. Sorry, 1050 newtons. 1050 newtons. Next, what would be the reading if the lift mechanism fails and it hurdles to the ground under the free fall of G? What happens then? Zero. His weight will become zero. Next. So, yeah, the last one, yeah, I don't get it. Like, is the answer? Oh, they have written in kgs only, Drupad. Yeah, I didn't see the whole question. Yeah, they have written it in kgs only. I'm so sorry. Next. So, conservation of momentum. The principle is this principle is a consequence of Newton's second and third laws. According to this principle, in the absence of an external force, the total momentum of a system remains constant or conserved and does not change with time. Okay, so basically the momentum is conserved, meaning what? Okay, Drupad, have you ever played billiards? When you play billiards, what happens? You basically have that stick and you're trying to basically hit one ball. All the balls are usually of the same mass, right? They are usually of the same mass. So if you hit the ball in a particular direction head on, what happens? At times you can actually see one ball stop and the other ball move, right? Okay, so this is what is happening here. You are getting a conservation. Your whole momentum is getting conserved. In the absence of an external force, the total momentum of the system remains conserved or constant and does not change with time. So if F external is equal to zero, then the system is called isolated system. Okay, if the external force acting on a system is zero, we call it what? We call it an isolated system. So let FAB and FBA are the internal forces in the system of bodies A and B in time delta t. Then what is delta PA? Change in momentum of A is equal to FAB. The change in momentum of A becomes equal to FAB times t. So we know that, right? But the formula for change in momentum is what? Impulse. Impulse is equal to what? Force into time. Am I right? Impulse is equal to force into time. Therefore, what is happening? A is equal to change in momentum of A is equal to Fa times B multiplied by delta T. Okay. Similarly, we can say that the change in momentum of B is equal to Fba times delta T. Clear? Now, both the forces are equal in magnitude but opposite in direction. So what ends up happening? FAB cross T becomes equal to minus of FBA cross T. So what is happening here? Delta PA is becoming equal to delta PB, right? Both of them are becoming equal. Therefore, delta PA plus delta PB becomes equal to 0. There should be a minus sign here. They have forgotten the minus sign. Okay. There should be a minus sign here. Therefore, the change in momentum of both the bodies must be equal to 0. Okay, the sum of the change in momentum of both the bodies must be equal to 0. The change in momentum of the system becomes equal to 0. Linear momentum of this isolated system remains constant. This is known as the law of conservation of momentum. Okay, now we are going to express explanation of conservation of momentum with the help of a derivation. Let us consider the momentum of two particle systems of masses m1 and m2 and p1 and p2 respectively. Then the net momentum of the system becomes equal to what? P1 plus P2. Suppose F1 and F2 are the two forces acting on the particles of masses M1 and M2. Let in a small time delta t, the change produced by the forces F1 and F2 are delta P1 plus delta P2, right? Delta P1. So basically, we know that if force is acting on an object, it will cause a change in momentum. So this change in momentum is becoming equal to delta P1 plus delta P2. So basically, the net change in momentum should also be equal to the change in momentum of 1 plus the change in momentum of 2. Yeah. So therefore, delta P upon delta T, we are dividing the whole equation by delta T. So delta P upon delta T becomes equal to delta P1 upon delta T plus delta P2 upon delta T. Now, if we take the time interval to be very, very small, if delta T approaches 0, what happens? Delta becomes equal to dt. So dP1 upon dt plus dP2 upon dt. Correct? Now, dP1 upon dt, change in momentum with respect to time is equal to what? Force. So, dP upon dt becomes equal to F1 plus F2. So, F1 is what? What is the value of F1? F1 is equal to F1 external plus F1 internal. So basically, what is the net force F1? F1 is the total amount of force that is acting on the body from the inside and from the outside. Okay, similarly, F2 becomes equal to what? F2 external plus F2 internal. Therefore, delta P over delta T becomes equal to what? F1 external plus F1 internal plus F2 external plus F2 internal. Okay, so delta P upon delta T, you can just interchange this again and again and again. From the Newton's third law, the internal forces always occur in pairs. The internal force should always occur in pair. So F1 external plus F2 internal must be equal to 0 because they are becoming equal to 0 only, right? So F1 internal plus F2 internal should be equal to 0. F1 internal should be equal to minus F2 internal. Okay, so from equation 3, we can say that minus F2 internal plus F2 internal plus minus F1 internal plus, sorry, F1 external plus F2 external. So basically, change in momentum is equal to what? This value, this whole thing. Only the external forces are there. Internal forces are becoming 0. So what is happening here? So you'll be left with F is equal to F1 external plus F2 external. Therefore, F external is equal to 0. The external force is all equal to 0. Therefore, the change in momentum becomes 0. Therefore, the change is conserved. Okay, Newton's third law always says that what? Internal forces is always occur in pairs. Okay, so basically, if me standing on the surface is a system, If me standing on the surface is a system, then me acting weight on the surface is equal to the what is equal in magnitude to the reactionary force acted upon by the surface on me. Therefore, what ends up happening? Both of us we are having the same magnitude but are opposite in sign. So that is what's happening here. F1 internal plus F2 internal is equal to 0. Are you having doubts, Drupad? I can't see you or anything. That's why I'm asking you again and again. Okay. So this equation shows that the law of conservation of linear momentum holds true. The law of conservation of linear momentum holds true if linear momentum of the system remains constant. Okay, so law of conservation of momentum is basically true for linear momentum if linear momentum of a system remains conserved. Conservation of momentum theorem is applicable for F external is equal to 0. It does not depend on the internal forces. No matter what happens internally, if the external forces acting on the object, if the external forces acting on the object end up canceling each other and become zero, then nothing happens. Okay, so nothing happens. Let us consider a bullet fired from a gun. Then the force on the bullet by the gun is F. And according to Newton's third law, the bullet will also exert a force on the gun. The bullet will also exert a force on the gun. Now, the gun is exerting a force on the bullet and the bullet is moving forward. But the bullet is also exerting a force on the gun and the gun is moving in the backward direction. Am I right? So, before the gun was fired, can I consider the bullet and the gun to be one single system alone? Can I consider the bullet and the gun to be one single system alone? Yes, I can consider the bullet to be one single system. So after the fire also, I can consider it to be one single system. Okay, so what is happening here? The force that the gun exerted on the bullet is not coming from outside, right? It is not coming from outside. You cannot count the trigger. Okay, it is not coming from outside. It is coming from the system itself. The gunpowder in the bullet is getting ignited and it is producing an internal force which is allowing the bullet to move forward. Okay, so only internal forces are applicable. On the external forces have no effect on the gun and the bullet system, right? Okay, so what happens here? Bullet the bullet will produce a force on the gun in the opposite direction equal in magnitude. So it will become minus F. The two forces act on a common interval of delta t. So according to the second law, if delta t is the change in momentum of the bullet and minus F delta t is the change in momentum of the gun, right? Because bullet and gun are initially at rest and then change in momentum of the system is also zero, the sum of their final momentum must also be equal to zero. Okay, so the question that they ask here is this: the gun has a mass of blah blah blah. The gun and the bullet have mass this and this respectively. When the gun is fired, the bullet attains a velocity of this much. How much will the gun with what velocity will the gun move in the backward direction? With what velocity will the gun move in the backward direction? Now, Drupad, this is one of the major reasons why guns are very, very heavy. The reason why a gun is heavy is to basically mitigate or minimize the velocity with which the gun will move backwards. We know this, right? See, both the forces are equal in magnitude but opposite in direction. So M1 V1 must be equal to M2 V2, right? So if you want to minimize the velocity with which the gun is moving backwards, just make the gun heavier. Make the bullets lighter and make the gun heavier. The heavier the bullet, the if you want to increase the weight of the bullet, you have to massively increase the weight of the gun as well. Clear? Understood? Is this clear? Like this is one of the major reasons why the gun has such a heavy mass. Okay, so because bullets and gun are initially at rest, then the change in the momentum of a system is zero. So the sum of their final momentum must also become zero. Thus, if PB is the momentum of the bullet and PG is the momentum of the gun, then PB plus PG must be equal to zero. They should be in equal and opposite direction. Therefore, their sum must be equal to zero. Clear? Okay. Let a bomb be at rest. Then its momentum will be zero. If the bomb explodes into two equal parts, then the parts flying off in exactly opposite direction with the same speed so that the total momentum will still become zero. You can do this at this experiment. You can place a small bomb, a cracker, a firecracker, right? A firecracker between two marbles. Okay, you can place a small firecracker between two marbles of equal mass. Okay, and when the firecracker, you need to record this with the slow mo camera. Okay, your iPhone slow mo camera. When you basically lit the bomb on fire, what ends up happening? Initially the momentum was zero, right? There was one marble to the left and one marble to the right of the bomb. So, what will happen? The bomb will exert a force in both the directions, opposite directions. So, what will happen? Huh? Both the marbles will shoot outwards. Both the marbles will shoot outwards with equal velocity, but in the opposite direction. So that what will happen? Their momentums will remain conserved. Okay, if one is traveling like this, the other will travel like this. Clear? Okay. You understood the concept of conservation of momentum, right? Any doubts here? Anything that you feel like I have to repeat it again? I don't mind repeating it again. No, no, it's fine. Okay, let's move on. So, here, no external force is applied on the system of the particle. The bomb force creates an initial forces are created internally only. Okay, only internal forces are getting exerted. Now, a moving neutron with a speed of 6 meters per second collides with a deuteron. What is a deuteron? Okay, collides with the neutron at rest and sticks to it. Find the speed of the combination if the masses of the neutron and the deuteron are 1.67 into 10 raised to minus 7 and 3.34. It is deuterium. Deuterium is what? Deuterium is what is deuterium, Drupad? It is a tritium, right? Yeah, one neutron, exactly. So basically, it's double the value. That's why I said. Okay, so a moving neutron with speed. I think neutron should be two neutrons. I guess. I don't know. It's not deuterium. It's anyway. It's not written deuterium. I think neutron will be two neutrons. Okay, so let's see. So Drupad, there is a neutron. I'm just going to write it D here, and there is a neutron here. Okay, and it is moving with a velocity of v. Okay, this has a mass of m1 and this has a mass of m2. Clear? So it is moving with a velocity v. This has a mass of m1 and this has a mass of m2. Now what happens when initially is there any force acting on the body? No. Why? Because the neutron is moving with a constant velocity. Okay, so what is the initial momentum of the system? m1 u1. So let's call this u. Okay, and let's call this u1 and u2. Okay, so m1 u1 plus m2 u2. Okay, if I so basically m1 u1 plus m2 u2 should be equal to what? After the collision, what happens? Both the masses are getting stuck, so it will be equal to m1 plus m2 into v, right? So m1 u1 plus m2 u2 must equate itself to m1 plus m2 into v. So what will be the final velocity of the entire particle? It will be equal to m1 u1 plus m2 u2 upon m1 plus m2. So in our case, what is happening? The u2 value is 0. So we will have v is equal to m1 u1 upon m1 plus m2. So let's see what happens here. Now we have the masses as 1.67 into 10 to the power minus 27. Okay, 1.67 into 10 to the power minus 27 multiplied by 10 to the power of 6 upon m1 plus m2, right? So 1.67 into 10 to the power minus 27 uh, plus 3.34 into 10 to the power minus 27 multiply that's it, right? So can I cut this 10 to the power minus 27 like this? I'll just take the 10 to the power minus 27 out and cut it from top and bottom, and I think that 1.67 is basically half of 3.34, right? So basically twice of 1.67 equals 3.34. So can I write this as 1.67 uh, 1 plus 2 at the bottom, and at the top 1.67 multiplied by 10 to the power of 6. So this 1.67 can get cancelled, so I'll be left with 10 to the power of 6 upon 3 is equal to how much? 10 multiplied by 10 to the power of 5 upon 3. So I'll be left with 3.33 into 10 to the power of 5 meters per second. Is it correct? Yeah, 3.3. Yeah, 3.3 into 10 raised to power 5, or they're saying 33.33 into 10 to the power of 4. Both of them are the same. Okay, so this is the logic behind conservation of momentum. Clear? Okay. Equilibrium of a particle. Forces which are acting at the same point or on a particle are called concurrent forces. Okay, so the forces which are acting at the same point on a particle are called concurrent forces. These forces are said to be in equilibrium when their resultant becomes equal to zero. For example, this is a point on a body. If one force is acting like this and the other force is acting like this, then what happens? The resultant force automatically becomes zero if both their magnitudes become the same. Okay, if the magnitude of both the forces are the same, then what ends up happening? You are getting net resultant force to be zero. Now, next. So, if two forces F1 and F2 act on a particle, then they will be in equilibrium. Yeah, yeah, sure. Okay, fine. One second. The equilibrium of the concurrent forces can be illustrated by the following example. If two forces F1 and F2 act on a particle, when then they will be in equilibrium if F1 is equal to minus F2. That is, the two forces on the particle must be equal and opposite. Three concurrent forces F1, F2, and F3 will be in equilibrium when the resultant of two forces F1 and F2 is equal and opposite to the third force F3. Okay, so again, what is happening here? F1 and F2 should be equal to F3. Clear? See, here, even though they are moving in, even though they are not all in the same line, this is pointing this like this is pointing like this. So, with the magic of vectors, what can we do? We can resolve it like this one can be resolved like this, and the other one can also be resolved like this, right? So basically, both of their cosines will be the ones that will be responsible for F3. Okay, so again, if the forces are equilibrium, then the net force becomes equal to the same, right? F1 and F2 must be equal to F3. Clear? Now, Drupad, I must ask you this. See, if this has to happen, then why is the object not moving like this or this? Why, da? Why is it only moving like this and this? If it is sorry, it's not moving. Why is it not moving like this or this but stationary here? because this object is experiencing not only a force in the vertical direction but is also experiencing a force in the horizontal direction. No, if we resolve this force F1 and F2, if the F1 and F2 forces get resolved, then the direction, there is a horizontal component too. Why is it not moving in the horizontal component at all? Why? Because the horizontal components cancel each other out. Okay, F1's horizontal component is cancelled by F2's horizontal component. You're only left with the vertical component. F1 and F2's vertical component are equal to what? F1 and F2's F1 and F2's vertical component is equal to the downward vertical component of F3. Clear? Explanation. Given forces given figure shows three concurrent forces F1, F2, and F3 are acting at a point O and represented by OA, OB, and OC respectively. Let us complete the parallelogram OACB, OAC dash B. We are going to complete the parallelogram like this. Okay. Now let us complete the parallelogram OAC dash B. The diagonal OC of the parallelogram represents F1 plus F2. The resultant of F1 and F2 from the law of the parallelogram forces will be equal to what? F1 plus F2 should be equal to minus F3. Or simply speaking, all the forces F1 plus F2 plus F3 should be equal to 0. The three concurrent forces are in equilibrium if their vector sum is equal to 0. Right? Three concurrent forces are in equilibrium if their vector sum becomes equal to 0. Clear? Okay, next. So, particle. Particle under the action of force F1, F2, F3, dash dash Fn will be in equilibrium if these forces can be represented by the sides of a closed n-sided polygon in the same sense. That is, F1 plus F2 plus F3 plus dash dash Fn becomes equal to 0 if we can represent it like this plus this plus this plus this plus this plus this plus this. Okay, so we know that in a vector formulation, what happens if you end up in the original place from where you begin? The resultant force, the sum of all the forces will become equal to 0. Yeah, exactly. Okay, so this is what the XYZ, the basically this is what it just means. Okay, it can, if all the forces acting on a body, if all the forces acting on a body end up being 0, if some of the all the forces acting on a body end up being 0, then what happens? Then we can represent all the forces as the sides of an n-sided polygon where n represents the number of forces acting on the body itself. Clear? Okay, let's move on to the next one. Lami's theorem. According to this theorem, when three concurrent forces F1, F2, and F3 acting on a body are in equilibrium, then F1 upon sine alpha is equal to F2 upon sine beta is equal to F3 upon sine gamma. So, what is alpha? Alpha is the angle opposite to F1, beta is the angle opposite to F2, and gamma is the angle opposite to your F3. Clear? So this upon sine alpha will be equal to this upon sine beta will be equal to this upon sine gamma. Clear? Huh? This is the proof. I'm going to tell you this. Okay, proof. Shown in the above figure, the forces F1, F2, F3 can be represented by the sides of a triangle ABC in the same order. We can represent this as the sides of a triangle. Can we? Right? We can represent these three forces. See, the previous law stated what? If the sum of all the forces acting on a single particle end up being 0, that is, if the resultant force acting on the particle becomes 0, then what happens? What happens then? then we can represent all the forces. We can represent all the forces as the sides of an n-dimensional polygon, right? That's what we did here. That's exactly what we did here. Now, what is happening here? See, so this is beta, this is gamma, and this is alpha. All you have done is what? Actually, the drawing is not accurate. It should have been made like this. Better? Wait, hold on. Hold on, hold on. Right? These three forces, they are concurrent forces. Can I represent it like this? So this becomes my F3. This becomes my F2. And this becomes my F1. If they are moving in the same direction, see, F2, F2, F1, F1, F3, F3. Right? So are they n sides of a polygon? Yeah. Now let's extend. So what is alpha, Drupad? Alpha is the angle between F2 and F3. Okay. Alpha is the angle between F2 and F3. So how do you make the angle between F2 and F3? You are going like this. Okay. You are going like this. So this becomes alpha. The angle between F2 and F3. Next. Beta is the angle between F1 and F3. Okay. Beta is the angle between F1 and F3. Let's make it like this. Is this equal to beta? Okay, and gamma is the angle between what? F1 and F2. Okay, let's see this. Okay, this can be considered to be gamma. Sorry, yeah, alpha, beta, and gamma. So what does this become, Rupert? Pi minus alpha, pi minus gamma, and pi minus beta. So now do you understand how they converted this into a triangle now? Any doubts till here? Okay, so applying the law of sine. You remember the law of sine from the previous chapter? This side upon this angle is equal to this side upon this angle is equal to this side upon this angle, the sine of. So all we are doing is doing that only. So we can say that f1 upon sine. What is opposite of f1? Pi minus alpha. Sorry, pi minus alpha is equal to f2 upon sine pi minus beta is equal to f3 upon sine pi minus gamma. Now, when I say pi minus alpha, where am I? In which quadrant am I on? When I say pi minus alpha, in which quadrant do you think I am? I'm in the second quadrant. And the second quadrant, who is positive? The sine and the cosec are positive in the second quadrant. So sine pi minus alpha can simply be written as sine alpha. So f1 upon sine alpha is equal to f2 upon sine beta is equal to f3 upon sine gamma. Am I clear? Is this accurate? Any doubts here? You have doubts? Okay, fine. It should be clear, Drupad. Understood? That's all I want. Hmm. Okay. The next one. The below figure in the part of the horizontal stretch net. Okay, now section AB is stretched with the force of 10 newtons. Where's AB? Oh, here. Section AB is stretched with the force of 10 newtons. Then determine the forces in section BC. Where is BC? Get it. The force, the below figure in this part of the horizontal stretch net, section AB. AB, I can see it here. Section AB is stretched with the force of 10 newtons. BC, oh, okay. Fine, determine the force. Okay, fine. Fine, then determine the force in the section BC and BF. Okay, so basically what is happening here is we can consider the force like this. Okay, this can be considered to be 10 newtons. Okay, so this can be considered to be 10 newtons. Now here we only have to focus on here. So this is what? This is F of BC and this is F of BF. Okay, now what is this angle going to be, Tripat? See, this angle is coming out to be 120 and this angle is coming out to be 120. So this also has to be 120, right? Okay, so we know the formula to be how much? F1 upon sine alpha should be equal to F2 upon sine beta should be equal to F3 upon sine gamma. Since alpha, beta and gamma are the same, then F1 and F2 and F3 have to be the same, right? See, F1 upon sine alpha should be equal to F2 upon sine beta. So basically, the sine 120 and the sine 120 gets cut off. See, F1 upon sine 120 should be equal to what? Your FBC upon sine 120 should be equal to what? F of BF upon sine 120 degrees. So if I cancel all the three, what will I get? F1 should be equal to F of BC should be equal to F of BF and all of them should be equal to how much? 10 newtons. Clear? So that's how they did it. I just didn't understand what the question was saying when I first read it. Clear? Okay, next. Hmm. Okay. So this is oh, we have already finished one section now. Okay, fine, very good. Uh, shall we do some numerical problems today before we start the next section? Okay, some common forces, friction, because the next section is like I want to do it tomorrow. Okay, so let's do some numericals. Let's see how many pages are left. Dynamic circular motion, 23, 24, 25. Oh, all of this is theory. I didn't take the numericals at all. Okay, fine. Oh, you're traveling, right? Okay, fine. Are you planning to come and visit me, Drupat? Huh? Huh? No. If you come to Delhi, sure. Okay. Just if you are coming to Delhi by any chance, you can meet me. Okay. Let's do some questions. Anyways, no problem, da. We can do a. Can I ask you one thing? When are you leaving tomorrow? One second, Drupal. One second. Come on. Let's start. Okay. A force of 36 dynes is inclined to a horizontal at an angle of 60 degrees. Okay. So, wait. Force of 36 dynes is inclined to the horizontal. Okay. The horizontal is like this, and the force is inclined at an angle of 60 degrees like this. Right? So, this, but is the force towards the surface? Find the acceleration in a mass of 18 grams that moves in a horizontal. What? A force of 36 dynes is inclined to the horizontal at an angle of 60 degrees. That is fine. Okay. Find the acceleration in a mass of 18 grams that moves in the horizontal direction. Oh, there is a mass here. Okay, there is a mass here whose mass is how much? 18 grams. And a force is being applied onto this mass. Am I close? Rupat, can you hear me? Yeah, but is this it? The wordings is pretty confusing. We are doing question number 10, Drupat. Okay. How much is one dyne, Drupat, in newtons? Can I solve it in dynes itself? I know it's of course theta. I was just thinking we can solve it in dynes itself, right? Like, no, we have to find the acceleration. No, F cos theta is the horizontal motion, is the horizontal force, but they are asking us to calculate the acceleration. I'm just thinking, can I do it without converting it into newtons? I guess so, right? We can do that. Okay, so the mass is in grams. I think we should be okay. Let's see. So, but I will be getting centimeters per second square. That is fine. Okay. So basically, this is the force. This force can be expressed as a horizontal component like this and a vertical component like this. Okay. So is the vertical component participating in the acceleration in the horizontal direction, Drupat? No, it is not. Basically, then what happens? This object will simply move in the horizontal direction with a force of, I can simply represent this as m moving with a velocity of, sorry, with a applied force of f cos 60 degrees. Okay, so what is cos 60 degrees? 1 by 2. So 36 multiplied by 1 by 2 is equal to 18 dynes. Oh, 18 nines. That's fine. Now, basically, um, yeah, so this is the force. We know that force is equal to mass times acceleration. Therefore, acceleration is equal to force upon mass is equal to, what is the force? 18 dynes upon mass is how much? 18 grams. So this grams and grams gets cut off. So I'll be left with 1 centimeters per second square. Correct? Okay, and I can write it in meters as what? 0.01 meters per second square is the acceleration. Clear? Okay, next question. Okay, so you solve with me, Drupad. Okay, that's what I'm going to do. You basically say what to do, and I will write it down. Okay, a woman throws an object of mass 500 grams with a speed of 25 meters per second. She's throwing it like this. So basically, this is an object of mass 500 grams, and she's throwing it with the speed of 25 meters per second. What is the impulse imparted to the object? What is the impulse, Drupad? Hmm. Can't I simply write the uh, yeah, change in momentum? Yeah, that's fine. Okay, fine. So the initial velocity is 0, the final velocity is 25 meters per second. So m v minus u becomes equal to impulse, right? So that is 0.5 into 25 is equal to how much? 25 5s are 125, so 12.5. 12.5 Newton second, right? That is the formula, that is the unit of impulse. Okay, next one. If the object hits a wall and rebounds with half the original speed, what is the change in momentum of the object there? Okay, so it had an initial velocity of how much? 25 meters per second. And its final velocity is now 12.5 meters per second. So change in momentum is equal to how much? 500 in, sorry, 500 is a lot. 0.5 into 0.5 multiplied by uh, 0.5 multiplied by 12.5, that is the final momentum, minus, no, 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 no. Wait. So if I consider this, yeah, no, 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 Drupal, no, 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 no. If I consider this motion as negative and the coming out motion as positive, what do I get? Hitting the wall is negative and rebounding backwards, if I consider it as positive, what do I get? Can I write it as 0.5 multiplied by 12.5 minus of minus 25, right? So I'll be getting 0.5 multiplied by 25, 35, 36, 37, 37.5. Okay, so 0.5 multiplied by 37.5. So 36 is 18, therefore 18.75. 18.75, right? Okay, 18.75 kilogram meters per second. Am I right? Okay, next one. Okay. 72.2 kgs is riding an elevator while standing on a platform scale. What does the scale read when the velocity is descending with a constant velocity, Drupad? You shouldn't even know need the paper. What is the scale reading, Drupad? You can say it in kilograms. I don't care. You can say it in kilograms. What does the scale read? Yeah, 72.2, because the weight is going to remain the same. The reaction is going to be the same as that of the weight, right? Since the reaction is going to be the same as that of the weight, therefore both the masses will be the same. So the scale will read 72.2 kgs. Okay, next. Now, ascending with a constant acceleration of 3.5 meters per second, it is going upwards. When it is going upwards, what happens? M G G plus A, exactly. So what happens then? So 72.2 multiplied by 10 plus 3.5 is how much? 13.5. This will become the answer. Then next. No, wait. What will be the scale reading? Yeah. Is this correct? Uh, no, we have to then divide it by 10 also, no, to get the mass. So we have to divide it by 10 to get the mass back. Okay, next. A person of mass 50 kgs stands on a weighing scale on a lift. If the lift is descending with a downward acceleration of 9 meters per second square, what would be the reading on the weighing scale? G is taken as 10. So he's going downwards. So Drupad, see, basically he's going down approximately at the speed of acceleration due to gravity, right? So can I say that his mass becomes half, approximately half? Half, right? Because he's going downwards, right? When he's going downwards, what happens? No. His weight, no, not half. 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 No, not half. 5 kilograms exactly. Because G minus A becomes equal to 10 minus 9 will become equal to 1. Therefore, 50 multiplied by 1 is equal to 50. Okay, his weight will become 5 kilograms. No, wait, what? Yeah. No, you have to divide by 10 also. I keep forgetting that you have to divide by 10. Now, when a lift descends with a downward acceleration, A. The apparent weight of a body of mass m is given as W is equal to, oh, we know this. We don't have to use this. But you understood the logic, right? His weight becomes 5 grams. Okay. A pebble of mass 0. Yeah, what? What, Drupad? Okay, next. A pebble of mass 0.05 kg is thrown vertically upwards. Give the direction and magnitude of its net force on the pebble. Hmm. When it is in the upward direction, what is the net magnitude of force, Drupad? Sorry, what is the net direction of force? When it is moving upwards, what is the net direction? Huh? No, da. The direction will be upwards only, no? Pebble of mass 0.05 kg is thrown vertically upwards. Give the direction and the magnitude of the net force. The net force will be acting upwards. That's why it is moving upwards. No, during its downward movement, what will happen? The downward motion, the net direction will be downwards at the highest point. Now tell me, this is the trick. At the highest point, what will it be? At the highest point where it is momentarily at rest, what will be the net direction of force? It should be downward, right? But it is momentarily at rest. When it is momentarily at rest, it has lost all its upward force. So it should have a downward. Let me just check the answer. One second. Yeah, it's vertically downwards. What will be the magnitude of force be, Drupad, when it is going upwards? Huh? Mg. Okay, fine. When it is going downwards, but the force is in the opposite direction, right? So it will become equal to 0.5 newtons in the upward direction. But what happens if it is going downwards? Same thing, but it's in the downward direction. Do your answer change if the pebble was thrown at an angle of 45 degrees with the horizontal direction, ignoring air resistance? Now, what would have happened? When the pebble is going upwards, the net force would have been, yeah, I know it's projectile motion, but the net force should be in the top. It should be in the direction of motion, right? Then only it will be able to move at an angle, right? Mm, they're seeing, um, if the pebble were thrown at an angle of 45 degrees with the horizontal direction, then the accelerating acting on it and therefore the force acting on it will remain unchanged, 0.5 newtons vertically downwards. That is, at the highest point, the vertical component of velocity will become 0, but the horizontal component will not be equal to 0. So basically, still the force will act vertically downwards. Oh yeah, because at a projectile motion, what happens? The horizontal component of velocity does not change at all, right? It becomes u cos theta only. The only component that is changing is the vertical component of velocity. Okay, therefore the force remains the same in the downward direction. One in the upward direction, the second in the downward direction. Clear? It will still remain 0.05 newtons. Sorry, 0.5 newtons. Hmm. But what about the 45 degrees? Velocity. No, 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 it's fine. It's fine. It's fine. It's fine. It's correct. Okay. A stream of water flowing horizontally with a speed of 15 meters per second gushes out of a tube of a cross sectional area of 10 to the power minus 2 meters square and hits a vertical wall nearby. What is the force exerted on the wall by the impact of water, assuming it does not rebound? Hmm. Should we find the mass? No. We know the velocity. We know the final velocity is going to become zero, right? Because there is no rebounding. Therefore, the final velocity will become zero. Initial velocity was 15 meters per second out of a tube and hits a vertical wall nearby. Oh, a stream of water flowing horizontally with a speed hits a vertical wall. So, what is the force exerted on the wall? Hmm. How do we know the mass of water? Hmm. Oh, but look at this. Okay, so the speed of the water is how much? 15 meters per second, right? The cross sectional area is how much? 15 into 10 to the power minus 2. 15 into uh, no 10 to the power minus 2. So 10 to the power minus 2 meters per second. Okay. Mm, so the volume of water coming out per second. The volume of water coming out per second will be equal to what? Volume is equal to area multiplied by velocity, right? Can it be? Because we are only considering per second, right? The volume of water coming out per second is what? Area multiplied by length gives us volume, right? Area multiplied by length upon time gives us volume of water per second. Okay, so this is becomes volume. Now, if we want to convert volume to mass, what do? We know that density is equal to mass upon volume. Therefore, mass is equal to how much? Density times volume. So, what is the density of water, Drupat? 1000 kilograms per meter cubed multiplied by area is how much? 10 to the power minus 2. This is meter square. This is not meters per second, it is meter square. 10 to the power minus 2 meter square. Okay, 1000 kilograms per meter cubed multiplied by 10 to the power minus 2 meter square and multiplied by 15. Yeah, meter square and meters per second gets cancelled. Okay, so what are we left with? These two zeros and this gets cancelled. 150 kilograms per second. Clear? We got the mass 150 kilograms per second. So what will be the momentum, Drupad? What will be the impact? M V minus U per second. The impact per second will be equal to how much? 150 multiplied by uh 25. It was 25, right? Yeah. No, 15. 15 minus 0. No, 0 minus 15, right? No, just it's just mass into velocity. The mass into velocity m v should be equal to 150 multiplied by 10. No, 15 is equal to 15. 15 are 2250 newtons. No, what was the question? Five zero newtons, right? No, wait. No, it's correct. Because there is time also here, no? There is mv upon t, m upon t. This is kilograms per second. So what do you get? 2250 newtons. Okay, because we are getting the mass in per second, 50 kilograms per second, and if we multiply that with the change in velocity, we should be getting acceleration. Velocity upon time gives us acceleration. So the unit will be 2250 only. Yes, we did it. We found the velocity. We found the force that was acting on it. Clear? Did you understand this question? Okay, next. So 10 1 rupee coins are put on the top of each other on a table. Each coin has a mass of m. Give the magnitude and direction of force on the seventh coin counted from the bottom due to the fall of all of the coins on its top. 10 1 rupee coins are put on top of each other. Each coin has a mass of m. Find the magnitude and the direction of the force on the seventh coin counted from the bottom. So only three coins of weight, right? Due to all the coins on its top, 3 mg, right? Yeah, it's 3 mg newtons. The seventh coin. This is the first coin, second coin, third coin, fourth coin, fifth coin, sixth coin. The seventh coin counted from the bottom will have the weight of only three coins on top of it. So the force acting on the seventh coin will be equal to how much? 3m multiplied by g. So 3 mg newtons. The force on the seventh coin by the eighth coin. Mg, right? The force on the seventh coin by the eighth coin is how much? Mg. But is the hmm. But they answer பண்ணடா. I The force on the seventh coin by the eighth coin. But should we consider the force, all the forces acting on the eighth coin? It's such a tricky wording, right? Yeah, that what I said is correct. What I said is correct. Yeah. See, but look at this. See, man, I saw the answer. Look at this. They're using the same thing. Force on the seventh coin by the eighth coin is how much? Weight of the eighth coin plus weight of the two coins on top. Again, you will be left with 3 mg only. So force on the seventh coin due to the eighth coin is not mg. It is again 3 mg. The force on the eighth, the weight of the eighth coin plus the weight of the ninth and the tenth coin too. So you will still have 3 mg newtons. The wording is very confusing, but still, I think that is the reason why the wording is confusing. The reaction of the sixth coin on the seventh coin. You tell me the answer here. The reaction of the sixth coin on the seventh coin. How much reaction will it give? The clue is that all of them are in equilibrium. How much? Yeah, 4 mg, because the weight on the sixth coin is equal to how much? 4 mg. So the reaction should also be equal to 4 mg only. Exactly. But in the opposite direction, because it's in the opposite direction, it will be minus 4 mg. Okay. Okay. Next. Helicopter's mass 1000 kg rises with a vertical acceleration of 15 meters per second square. The crew and the passengers weigh 300 kg. Give the magnitude and the direction of the force on the floor by the crew and the passengers. The crew and the passengers. Okay. So they are asking us to tell you. Hmm. It's moving vertically upwards, so they will experience a higher weight. So the 300 multiplied by 15 plus 10, right? They didn't say the helicopter, they just said the force on the floor by the crew and the passengers. So basically 300 multiplied by 15 plus 10, m multiplied by g plus a, right? Because it's ascending, right? Since it's ascending, am I right or wrong? Okay, so what will be the answer be then? Take the value of g as 10. Vegam Padna, what is the answer? So you can do it in your head. It's 25 multiplied by 300, no? 7500 newtons. Yeah, next. Action of the rotor of the helicopter on the surrounding air. It is pushing the surrounding air downwards, right? It is pushing the surrounding air downwards. Huh? Mg. But what is the answer going to be, Drupad? 1300 into 25. Yeah, 1325 is the correct answer. Force on the helicopter due to the surrounding air will be how much? Same value with the opposite sign, right? Okay. So, with this, we have finished this section. Okay. The first part of this video has been completed. Okay. So, I'll put some assignments on the website before you land in India. Okay. So, students, we are going to end the video here. If you like my video, please do like, share, and subscribe to my channel. And I'll again bring these long form videos to you where I explain each and every step in detail. And please, again, I'm requesting you like, share, and subscribe. And I'll meet you in the next video.